What's up, everybody? Today we have a free fall kinematics problem. What we're going to be doing is we're going to throw a ball straight up with an initial velocity of 5 meters per second. The ball is going to rise, it's going to come up, and it's going to come back down. We're going to catch the ball at the same height at which we threw it. And our goal is just to calculate a few things. For example, how high does it go? How long is it in the air, etc., etc. So let's go ahead and set up this problem. The first thing really we should do is write down all the known values in the problem. I'll usually refer to these as the givens of the problem. So let's write down what we know, what's given to us. So first of all, we know obviously the initial velocity is 5 meters per second. Now, since we're looking for how high the ball goes up here at the top, so right up here, we basically know that the velocity there is going to be 0. And that's because as the ball's rising, it's going to be slowing down, 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 down until it reaches the top, temporarily stops, and then it's going to accelerate back downwards. Okay? And the third thing we know is the acceleration. Now this one, we know it's gravity, right? It's in the air, it's gravity. The question is it a positive acceleration or a negative acceleration? Well, to think about this, remember the ball's on the way up with a positive velocity, but it's slowing down. And so that's because gravity is in the opposite direction of the velocity, so it's going to be slowing it down, correct? So that means we're going to give this a negative value here for a negative acceleration. Okay, so those are three things. The first question says, what is the maximum height? So we're looking for the height at the top. So I'm going to refer to this as the displacement, or delta D here. And then we just look through our list of equations and we try to find out which one's going to work for us to solve this problem. So I'm going to choose this one, VF squared equals VO squared plus 2A delta D. And there we go. Then we'll just go ahead and solve for this problem. Okay, so the velocity at the peak we said was 0. The initial velocity was 5. Our acceleration is negative 9.8. And then we're looking for our displacement. All right, do a little bit of algebra here. So this will be 5 squared divided by 2 divided by negative 9.8. Actually, when we subtract that 5, right, that's going to give us a negative 5 squared. Okay, and you go ahead and solve that. Do it on my calculator real quick. And I get 1.28 meters. So this would be the maximum height, or I'll usually call this the displacement or the height at the peak. So how high it reaches to go to the peak. Okay, so that's our letter A here. Let's go ahead and solve for B. So B is saying, well, how long does it take to reach that height? Okay, so let's go ahead and set this one up. So similarly, we'll write down what we know. So actually we know everything else. We actually know one more thing. Now, whenever possible, try to solve for that fourth value using things that were already given to you and not calculated values. So in case you make a mistake, right, you don't double make it. So let's use this equation in this case. So we use VF equals VO plus AT. So again, my V final is 0, my V initial is 5, and then we'll go negative 9.8, and we'll solve for T. All right, so that gives us negative 5 divided by negative 9.8 equals T. When I solve for that, I get 0.51 seconds. So letter C, we're now looking, how fast is it moving when I catch it? So remember, the ball's going up, it's going up, 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 slowing down, coming back down, 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 and then we're now going to catch it right here. Okay, so how fast is it moving when I catch it? Now notice the givens that I did here, this was based on reaching the top. How fast was it moving at the top, right? So when I catch it, okay, obviously when I catch it, the velocity is still 0, but that's not what it's asking for. It's asking like right the split instant before I catch it. That's what it's looking for. Okay, so in that case, let's look at our given. So we still know the initial velocity is 5, right? We still know the acceleration is negative 9.8. Okay, remember, gravity is negative 9.8 on the way up, but then also on the way down, we have a velocity coming down, and the acceleration is also down. That's why we're speeding up on the way down. So on the way up, we're slowing down. It's in opposite directions, but on the way down, it's going to be speeding up. They're in the same direction. All right, so I'm going to basically do a new set of givens. We're going from the hand. We'll call this going from the hand to the hand, right? So the initial velocity is still 5. The acceleration is still negative 9.8. Again, it's like that the whole trip. Now, the third thing we know is our displacement. So our displacement's actually going to be 0 because we catch it at the same height at which we threw it. Okay, so we started here, we ended here. That's a height, that's a displacement of 0 here. So those are the three things. Then I'm going to go ahead and choose an equation to solve this. Let me give it a little more space here. Let's use this one. Actually, let's use the same one we used before. So we'll go VF squared equals VO squared plus 2AD. Now notice what happens. We just said that D was 0, right? So basically you're saying, oh, VF squared equals VO squared. So VF is obviously the same 5 meters per second. Okay, mathematically it's obvious. Now one thing to notice is we are square rooting a number. Whenever you square root a number, you have either a positive or a negative answer mathematically. In this case, since our ball is falling, at this point, it actually has a negative velocity right here. So notice what happens. Our velocity is the opposite, the same speed, but in the opposite direction. And this will always happen. Remember, we're making a big assumption, and that is that there is no air resistance. This would be different if there was, and we'll deal with that in a future problem. But for today, it's going to be exactly the same. So for future problems, you can go ahead and make this assumption that if you catch it at the same height, as long as you catch it at the same height, then the speed up will be equal to the speed down, okay? And probably intuitively, you're going to know the answer for letter D. How long is the ball in the air? But let's go ahead and mathematically prove this. Intuitively, I hope you would assume that it's going to be the exact same time on the way down. But let's go ahead and mathematically prove this one. All right, so we'll go ahead and use the same equation we did before, VF equals VO plus AT. And our VF now we know is negative 5. Our V initial was 5 equals negative 9.8 times T. Okay, so when you do this, you get negative 10 divided by negative 9.8 equals T. And that equals 1.02. Okay, so notice this number, 1.02. What was my other time? Here it is. 0.51, 1.02. That's exactly double the time, right? So the time total is exactly equal to twice the time to the peak. Okay, again, you can use this now in future problems. Again, though, the key idea is this is only true if you end up at the exact same place. So once again, right here, exact same place. So this would be different. Let's say you let the ball hit the ground, then that's going to be a little bit longer, right? And so it's not going to be exactly double. Or if you catch it up here a little bit higher, it's going to be a little bit less. Okay, so keep that in mind for future problems. All right, I hope that was helpful. Let me know if you have any questions. Please comment below if you do, and I'll do my best to get back to you. Thank you.